A wedge of mass 11 kilos is held on the ground with its base horizontal and smooth faces inclined at 30 degrees and 45 degrees to the horizontal. 5 kilogram mass on the face is inclined at 30 degrees, is connected to a 7 kilogram mass on the other side of the face by a light inextensible string which passes over a smooth light pulley. The system is released from rest and the wedge does not move, and this was the diagram given. So let's have a look at the forces at play here. Let me start with my 5, 30, 5, my reactionary force between the particle and the wedge going that way, coming down this way. Let me just make this a bit smaller. We have 5G. Call this R1 because we're going to have a different one on the far side. This one. We got inside 30, so 5G cos 30. Going in this direction. We have 5G sine 30. My acceleration is moving up the incline. And my tension is also going, that's A, my tension is also going up the incline. So we're going to have T minus this one here. T minus 5G sine 30 is 5G over 2. And that's equal to M times A. We look at the 7 kilogram on the other side. We have 45. We have our 7. 7G. We have a reactionary force, we'll call it R2. Tension going back up the hill and acceleration going down the hill in this direction. We have 7G cos 45, and in this direction, parallel to the incline, we have 7G sine 45. So we're going down, so we're going to start with our 7G sine 45, which is 7G by 1 over root 2, or just 7G over root 2, minus T is equal to 7 times A. And resolving these, we can find A, we can bring this down here and put our minus 5G over 2 plus T is equal to 5A. So 7G over root 2 minus 5G over 2 is equal to 12A. So bring that 12 underneath, type it into your calculator, and you're going to get A is equal to 2.0006. So we'll just take 2 meters per second is A. And if we find tension at the same time, we can use this one. Tension is equal to 5A plus 2.5G, 5A plus 2.5G. So tension is equal to 5 times 2 plus 2.5 times 9.8. And that's going to give us 34.5 newtons. So that's the tension. Okay, so we look at the vertical force exerted on the ground. This is the start of the diagram. There's a few more things to add. We have 11G going down this way. These are also vertical forces that are connected to the string at the top. So this is opposite 45, so this is going to be T sine 45. The one on the left here is going to be T sine 30. And we do have these forces as well. R1 and R2, I changed it to black up here. R1 is equal to, just move it up a bit. R1 is 5G cos 30. 5G cos 30. And R2, that's going to be, R1 is going to be 5G by cos of 30 is a root 3 over 2. R2, this one, this will help us get the vertical forces. R2 is equal to 7g cos 45. R2 is equal to 7g cos 45. So R2 is 7g by 1 over root 2, 7g over root 2. Then if R1 is over here, and it's going in this way, we want this force along here. Now we have a 30. So we're looking at, we're adjacent to my 30. So we're looking at R1. R1 cos 30. And similarly over here, we have R2 going in this way. So we're looking for this one. This is your R2. So the angle is 45. So this side, we're going to have again cos R2 cos 45. So if we bring them down here, we have this R1, we call it R1, is going to become 5g by root 3 over 2. So 5 root 3 over 2 times g by the cos of 30, which is another root 3 over 2. So that's going to give me 5 times 3 is 15g over 4. 15g over 4. This one is going to become 7g over root 2 times 1 over root 2 cos 45. So we're just going to get 7g. So that's two of them. We also have our 11g, this one, and we have the two at the top that are connected to that part of the string. I'm going to have to add all these together to get what R3 is, the vertical force exerted on the ground. So we have t sine 30 and t sine 45 plus t sine 30 and t sine 45. Now we have t from here, so that's plus 34.5 by the sine of 30, so just over 2 plus 34.5 over root 2. So if we add all these up, what are we going to get? Let's have a look. 15g over 4. So on a calculator, type all these in. Before I do, I'll just correct. This was 7g over root 2. I'm just spotting, so these root 2's don't cancel. So that's 7g over 2. Over 2. Just be careful. So type these in. And you get 220.495 newtons. Were we asked to round off in this question? You were just told the vertical force, so we could leave it at that, or you could round off to 0.5. So that's that question complete.